Hey everyone, and welcome to The Explainer. Today, we're diving deep into the world of SQL. We're going to take a journey together, starting right from the absolute foundational basics and climbing all the way up to the high-stakes concepts you are absolutely going to need to ace those technical interviews. It's going to be a blast, so let's get into it. Okay, let's dive into this. Here's our roadmap for today. First, the language of data. Second, building and querying tables. Third, connecting data with joins. Fourth, advanced query techniques. And finally, number 5, acing the SQL interview.
So, you might be wondering, how do the world's biggest apps actually talk to their data? I mean, it's a fascinating question, right? Behind every single app, website, or digital platform you use on a daily basis, there is a database humming away. And structured query language, SQL, is the universal translator. It's literally the bridge we use to communicate with, organize, and extract meaning from oceans of raw data.
Section 1. The language of data.
Now, what's really interesting about this slide is how neatly SQL categorizes its own commands into these 4 primary families. First up, we've got DDL, or Data Definition Language. This is all about defining the database schema, using commands like create, drop, and alter to build the actual structural foundation. Next is DML, the Data Manipulation Language. Think of this as how you play with the data itself, using insert, update, and delete. Then we have DCL, Data Control Language, which handles your access rights with commands like grant and revoke. And finally, TCL, or Transaction Control Language, which deals with database transactions through commit and rollback.
Section 2. Building and querying tables.
All right, let's look at the basic life cycle of data creation step by step. Step 1, you create the database itself. Step 2, you create the table. Notice how we're using DDL here to build that structure, right? You define your columns, like customer ID, first name, last name, and you set up your constraints, like primary keys. Then comes step 3. You use DML to insert the actual values into that structure, and just like that, boom, you've gone from a totally blank slate to a functioning, breathing data repository.
But when we start querying and organizing, that is where the real magic happens. Once our data is actually in the table, we can use clauses like group by and having to filter and summarize our records. And this brilliantly illustrates how raw, disorganized data transforms into a grouped output. Instead of just staring at endless rows, we can instantly see things like employees grouped by gender, calculate their average salary, and filter out the exact subsets we need. It's incredibly powerful.
Section 3. Connecting data with joins.
So, because data is usually separated into different tables to keep things running efficiently, we have to use joins to bring it all back together. Think of a join as a highly efficient matchmaking service for your data. An inner join? That only returns records that have matching values in both tables. A full outer join shows you absolutely everything from both sides, the whole shebang. A left outer join gives you all the records from your first, or left table, and only the matched records from the right. And a right outer join, as you probably guessed, does the exact opposite. You're basically telling SQL exactly how strict or loose you want that matchmaking process to be.
Now here is a really cool concept, the self-join. Sometimes the relationship you're looking for is actually entirely contained within a single table. Our source material gives a perfect example of this with a staff table. Let's say you want to match an employee to their manager, and both of those people are listed in the exact same table. Well, you just join the table to itself. So you can seamlessly output a list showing that Aming Hong reports to Kelvin Ko and Kelvin Ko reports to Tan Mei Ling, all from one single source. How cool is that?
Section 4. Advanced Query Techniques.
All right, we're moving into the advanced toolkit now, the boss fight level of SQL. First up is the CTE, or Common Table Expression. I want you to think of a CTE as your personal digital scratchpad. It's a temporary result set that exists strictly in memory. It's not physically saved in the database. Because it creates this temporary holding space, it is absolutely perfect for organizing and manipulating really complex subqueries before you execute your final main select statement.
Next up, window functions. These are absolutely crucial to master. While a traditional group by collapses your data into single summary rows, partition by allows you to perform calculations on a specific group while keeping the overall row detail completely intact. You can also use functions like row_number to assign unique sequential integers to your rows. And if you're ranking things, like, say, salaries, you can use rank, which leaves numerical gaps if there's a tie.
or dense rank, which maintains a perfectly sequential rank without any gaps at all.
Section 5, Acing the SQL Interview. All right, it's time for the ultimate test. Let's kick off a rapid-fire sequence of compare and contrast concepts you'll definitely see in an interview. First up, delete versus truncate. So the crucial point is that truncate is significantly faster. Why? Because delete is a DML command. It goes row by row, locking each row and logging each deletion. Plus, you can use a where clause with delete. Truncate, on the other hand, is a DDL command. It uses a table lock and simply deallocates the data pages used to store the table data. But remember, and this is a big one, you cannot use a where clause with truncate. It just drops the whole structure clean.
Next up in our rapid-fire session, where versus having. This one is all about the order of operations. You use the where clause to fetch and filter raw rows from memory before you group them. But once you've actually summarized your data with a group by clause, you have to use having to filter those grouped results. That's precisely why having is designed specifically to work with aggregate functions.
Okay, let's look at stored procedures versus functions. Think of a stored procedure as a saved recipe for complex database operations. It can use DML to alter data, and it fully supports transactions. A function is a much quicker, reusable tool. It cannot alter data with DML, no transactions are allowed, and it absolutely must return a single value. And here's the real difference. You can use a function inside a select statement, but you cannot do that with a stored procedure.
Now for indexes, clustered versus non-clustered. Let's use a quick analogy here. A clustered index is like a physical phone book. It physically sorts the actual data rows in the table. Because of that, you can only have exactly one clustered index per table. A non-clustered index, that's more like the index at the back of a textbook. It creates a separate list of pointers directing you to the data. And because it's a completely separate list, you can have multiple per table, up to 999 in modern SQL Server versions.
Watch out for this next one. It is a classic gotcha interview question to test if you actually understand constraint limitations. Primary key versus unique key. Both of these ensure data uniqueness, for sure, but a primary key absolutely does not allow any null values, and you are strictly limited to one per table. A unique key, however, allows exactly one null value, and you can actually have multiple unique constraints living within a single table. And finally, our last flashcard. Local versus global temporary tables. A local temporary table is prefixed with a single hashtag. It's completely private, available only to your current connection, and clears out the exact moment you close it. A global temporary table uses a double hashtag prefix. It's a shared resource available to any connection, and it only clears out when the very last connection to it is finally closed. And, take a breath, we made it through the advanced flashcards. Incredible job sticking with me through that high-level material.
We have covered immense ground today, from the basic grammar of DDL and DML to the intricacies of window functions and advanced technical interview concepts. We now have a remarkably structured understanding of SQL right at our fingertips. You have the tools, you know the answers. So, what will you build next? Take this knowledge, apply it to your projects, ace those upcoming interviews, and keep exploring the amazing world of data. Thanks for joining me on this explainer, and happy querying!